So before we start on the chapter 10 notes, a couple things. First, make sure you notice that I changed the homework so they're shorter. Second, I think there's some stress about exam 1. Don't be stressed about it. If we need to bump it back so it's not March 31st, that's okay. We'll figure that out. Right now, just worry about getting all these homework assignments done and your quizzes done. We'll tackle the exam next, but right now, don't worry about the exam. The last thing I want to say before we start these notes is I have posted discussions for each chapter. Put your questions, whether it be about the actual lecture slides or about the homework there, and I will make a video answering those questions and post those videos so you guys can look at how I do problems, how I solve them, or I can re-explain something if it wasn't clear, that kind of stuff. I think that will also be a good way where we post those discussions to see, oh, I'm not the only one struggling with this specific problem, and you guys can even help each other out on that discussion. So we'll be looking at those discussions. There's one for each of the chapters that I've got video recordings for, so you can ask questions there, and I'll cover all those answers in a video sometime in the near future. Okay, chapter 10. These are the objectives. So with chapter 10, we have what's called explanatory variables and response variables. And we've had this all along. I shouldn't say just in chapter 10. But we have two different variables. So for example, if we're talking smoking versus lung cancer, we have an explanatory variable, that would be the smoking, and the response variable would be lung cancer. One explains, one shows the response of that specific variable. So we're going to be talking regression, which means like lines of best fit. You might remember that from a couple years ago in math. Regression uses values of one variable to predict values for a related variable. And you guys, if you study any articles on the coronavirus, you'll see some regression in that. Some lines of best fit showing scatter plots, showing predictions for the future. They're using regression or some version of this line of best fit that we're going to be talking about here. The variable you are trying to predict is called the response variable. It is graphed on the y-axis. So the predicted variable is the y. The variable you already know is the explanatory variable, and that's the x. And remember, just because there's a relationship, that doesn't mean there's a causation. Two things might be related to each other, such as shoe size and height, without shoe size causing height. Okay, we've looked at the scatter diagram before. This shows a bunch of pairs. Those pairs show a father's height and a son's height. The average for the fathers and sons, the average ordered pair, let's see, which one's the explanatory variable? So this is the x, and this is the y. That tells us the average, or the center of this football, is at the point 67.7, 68.7. Because our sons is on the y-axis, our fathers are along the x-axis. Let's go back to that slide. So this point right here should be at 67.8 and 60, or 67.7 and 68.7. That's actually more like this. This line, this black line, is the line y equals x. And it does not go through that point of averages. So we're going to look at a couple different lines. What we want to do is draw a line that does go through all the averages along each specific set of inches for fathers. So it's going to look maybe more like that red line. I don't even like that red line though. Let's look something more like this. We've got two options. We've got the SD line, and then we'll also look at the regression line here in a few minutes. This SD line, you'll see it is basically that red line I just drew on the previous slide. It's just moved up a little bit from the y equals x, and it does hit our point of averages. You don't need to know too much about the SD line. We won't use it a ton. We care more about the regression line. But we do want to cover a little bit about it because every once in a while the SD line is used for stuff. So the next few slides, we're going to talk about it. The SD line goes through the middle of the football. So it goes through that point of averages and just through the middle all the way across. It goes through the point of averages and it has a slope of the standard deviation of y over the standard deviation of x. If it's positive, it's going to be a positive slope. If it's negative, it's a negative slope. So if we have a 5-number summary, we will be able to find the line or the equation for the line that goes through the point of averages and has this specific slope. To do that, we're going to follow these steps. So we've got 3 steps right there. We're going to put a dot at the point of averages. So from our 5-number summary, remember the 5-number summary is average x, average y, SD x, SD y, and r, and you actually don't even need r for the SD line. We will plot the average x, average y, and then we will do the SD of y over the SD of x because it tries overrun, so it's the x over y, or y over x. So from the point we're given, we'll count the rise over the run and put a second point, and then we just connect the dots. And that gives us our standard, or our SD line, standard deviation line, through those dots. And we can use that to predict a y value. So here we go. We've got our 5-number summary. I'm going to check this out before I go on. Yeah, the midterm is the x, final is the y, because that is the x-axis and the y-axis. So step 1, when we want to draw the SD line, is plot our point of averages. 75, 70, 75, 70. Oh, it's close enough. Okay, then we're going to use our standard deviations. 12 over 10, which simplifies to 6 over 5, which means I need to count up 6 and right 5. And plot my second point. Okay, it's kind of hard to read where those points are at, so before I draw my line, I'm going to write where they're at. 75, 70 was our point of averages. And then the next one I had to go up 6. That gets added to the y, because up and down is the y. And I had to go right 5. That gets added to the x. So this point is 80, 76. And then draw a line. That is our standard deviation line. We can use that to predict what somebody would get on a midterm or on a final if we knew their score. So for example, I knew somebody scored a 70 on the midterm. I would predict they'd get a 65 on the final. Someone who is exactly on the SD line is the same number of standard deviations above the average in y as they are in the x. So what that's saying is if somebody is right here on the standard deviation line, they scored a 70 and a 60, that's probably more like a 63, then they are exactly the same amount of standard deviations, or z-scores, away from the x average as the y average. So for example, if I take one standard deviation above the average, so 75 plus 10 is 80, and one standard deviation above the final, 70 plus 72, so I did 75 plus 10, I forget that you guys can't see when I point at things, I gotta point with the pen. 70 plus 12 is 82. If somebody scored 80 and 82, and they would be oh, I did my math wrong there. Let's try that again. 75 plus 10 is 85. That's why I was so confused. So somebody at 85, 82 is exactly 1 standard deviation above the average for the x and 1 standard deviation above the average for the y. And notice they will be on that SD line. Okay, that's what that's saying. Yeah, that's all what that's saying. Standard deviation goes through the middle of the football. It goes through this point. It's probably the line you would draw if I said draw a line through these dots that follows the pattern. But it's actually not used for predicting the y usually. So you can, but we found a better method, and that method is called the regression line or the line of best fit. What the line of best fit does is it takes care of the fact that this right here is too low for this specific inch, and that line is too low, and this is too high for that specific inch. So what the regression line does is it takes each of these inches, so I think this is for 63 inches, and it finds the average for 63 inches. And then it will find the average for 64 inches. And find the average for all of these dots in this section. It will find that average. And so on, it will find the average for each specific inch and then draw a line through those averages. So that's the line we're going to use from now on. The standard deviation line is there. Originally, statisticians started with it, but they realized there is a better method called the regression line that more accurately predicts y's from the x's. The standard deviation line is always going to be steeper than the regression line. So the standard deviation line will always be steeper, the steeper one. And I want to show you why that is. We have a formula for creating the regression line. These lines are y equals mx plus b lines. So way back in 8th grade, your 8th grade teacher, which for some of you that was even me, taught you y equals mx plus b. That's what these lines are. We're just going about finding the equations a different way. So this is the standard deviation line. This is the regression line. And you can see if I take the average for each specific inch, so for 62 inches, this is the average for all the sun sites. And the average for 68 inches, this is the average for all of those, and so on. And draw a line through those averages. That line follows the trend of the data a lot better and can be used to predict a lot better. The reason the regression line is shorter, we'll come back to this slide in a minute, is because of, or not shorter, sorry, is less steep, is because of how it's calculated. We still use the average, but then our slope, after we put a point at the point of averages, so after we put our dot there, to count the rise over the run, we use this formula. So R is the correlation coefficient, and it's this really cool thing. There's a bunch of math behind it to get this slope, to make sure that this slope goes through the averages. We don't need to know that math, we just need to take advantage of this formula. So we'll use this to get our rise over run, and then 3 we would connect the dots. So that's why the slope is always going to be less steep for the regression line, because the slope for the SD line is SD of y over SD of x. The slope for the regression line is R times SD of y over SD of x. And R is always going to be, the absolute value of R is always going to be in between 0 and 1. Which, if you multiply any number by some number in between 0 and 1, it decreases that number. So the slope is smaller, so it's less steep. Okay, back to this slide that I skipped over. This number right here, this 10, is saying how many sons there were, how many father-son pairs there were. And then this point shows you the point of averages for the oh, this is not fathers and sons anymore. This is height and counts. But this is saying there were 10 people measured, all the 76 inch people, there were 10 of them. They had an average of 195 pounds or whatever that might be. Okay, these are the steps that I just talked about to create your regression line. So now let's practice doing that. Same information as before when we drew the SD line, but this time to draw the regression line, we start with plotting this point, 75, 70. So 75, 70, right here. A little too high, let me move it down. Okay, good enough. The slope is the standard deviation of y over the standard deviation of x multiplied by the correlation coefficient. So that is 0.7 times 6 over 5, which means we're going to get a decimal there, and that's okay. Real life has decimals, so it's fine if we run into decimals rather than exact numbers. It does make drawing your regression line just a little bit messier. That's fine. We can still deal with that. In order to deal with that, I'm going to multiply the top by 0.7 and keep the bottom as 5. So, and you can also do the same thing. Keep the top as 12 and leave the bottom as 10. 7 times 6, that's going to be 0.42 over 5. So what that means is for every 4.2 over 5. Every 5 that I go to the right, I've got to go up 4.2. And I'm not really going to be able to get that graphed exactly. So in order to plot that point, I'm going to take my point of averages, 75, 70, and I'm going to add those values to it. Remember, it's the rise over the run, so this is the y, this is the x. So I'm going to add 5 and add 4.2. 80 and 74.2. So my next point is going to be 80 and 74.2. That right there. There's my line. 75, 70, 80, and 74.2. And I want to get one more point. So I'm going to do this step 2 again, just because I want to show you. On that previous one, I simplified the 12 over 10 to 6 over 5, because my brain automatically does. But let's see if we don't do that. Then this becomes 0.7 times 12 over 10. I said we can do this, so let's just check and make sure. 7 times 12 is 84, so that's going to be 8.4 over 10. So what that means is my original average, 75, 70, I need to add 10 to the x, 8.4 to the y. Rise over run. The rise is y, the run is x. So I'm going to add 10, and add 8.4. That's 85 and 78.4. That point should be on this line that I just drew. So let's check it. 85 and 78.4. Close enough. Might not be exact because this is not an exact graph. Oh no, I lost that point. Okay, 85, 78.4, right there. Good enough. Oh, and then we connected the dots. That was step 3. Okay, let's look at some examples for this. So for California women, the slope of the line for predicting income from education is $2,176 per year of education. So what that's saying for our slope is for every year of education, on average, the income increases by $2,176. The second line says, assume the scatter diagram is football shaped. All this says is it's linear. So can use regression. So can use hard and regression. your normal thing. Okay, we need to say true or false with these. So associated with each year of education, there is an increase of $2,176 more in income on average. That is true. That is what a slope is saying. So if I put units on this, it's 2167 per 1 year. So for each 1 year extra in education, there's an average increase of $2,000. B says going to school for an extra year will cause your income to increase by exactly 21,076 or 2,176. That's false. That's just an average. Going to school an extra year typically does not, or it won't raise your income by a specific amount. Typically, you have to go to school another 4 years before it actually raises or get a degree. Those who have a 4-year degree earn on average 2176 more than those who just completed high school. Okay, the problem here is it says 4 years, and this is for 1 year, so that's also false. The regression line goes through the point of averages and has a slope of R times SD of Y over SD of X. That is going to be the slope I need you guys to remember. You'll have a formula sheet when we do get to the exam, and this formula will be on it, but I won't tell you what it's for. So you need to remember that that is the slope for drawing the regression line. I don't care much about the SD line. I don't anticipate you'll ever see questions on a quiz or test about the SD line. So it's the regression line that I really care about. Predictions using the regression line, that's the whole reason we use the regression line, is to predict a specific Y from X's. So we can predict what's going to happen based off of data that we've seen. There are 4 steps to estimate the average value of Y from X. These 4 steps, I'm going to teach you in a little bit how to use the equation for the line. So these 4 steps, we'll find another method, and you'll have 2 different ways to estimate the average value of Y from X or predict Y from X. But these are the 4 steps we're going to use for right now. So we find out how many standard deviations the given X is above or below the average in the X value. In other words, we find the Z-score for X. So I'm going to call that Vx. We multiply that answer by R. So we take our Z scored for X and multiply it by R. Then we multiply what we got in step 2 by the SD of Y. So now we're going to take R times Z of X and multiply it by the SD of Y. Cool thing, when you multiply the Z scored for X times R, it becomes the Z scored for Y. So what you're actually doing here is multiplying the Z scored for Y by the standard deviations, and that will give you how many points above or below the Z or the Y value should be. So then you take that, I'm going to write it this way, R times Z of X times SD of Y, and add it to the average of Y. Okay. All those steps probably mean absolutely nothing to you right now. I want to do it a couple times so that they can mean more to us than just a bunch of letters that kind of maybe have words you understand. So we are given a 5-number summary. The average for the X is 70. Standard deviation for the X is 3. Average for the Y is 162. Average, SD for the Y is 30. And R equals 0.47. Okay, I guess I should check, are we actually predicting weights? Oh yeah, we are predicting the weight, so it says approximately what is the weight, so this is what we're predicting, which means weight is the Y, given the height, so height is the X. I didn't check that, I just assumed the top was X and the bottom was Y. You do want to check that to make sure, just so you don't do the whole problem backwards. So the average weight of men who are 76 inches tall. what I want to know is if I were to draw the regression line on a graph, what weight would be associated with a 76-inch tall man. So we've got these 4 steps. Step 1 is to change 76 into the z-score. So we're going to call that z of x. Z is entry minus average over standard deviation. And since we're dealing with the z for x, we're going to do 76 minus the average for x is 70 over the standard deviation for x is 3. 76 minus 70 is 6. 6 divided by 3 is 2. Okay. Step 2 is to multiply r by that answer we got in step 1. So 0.47 times 2 is I don't know why I'm doing this in calculator. I know that in my head. 0.94. What that's saying is somebody who is 2 standard deviations above the average for height is going to be 0.94 standard deviations above the average for weight. We get that from our 0.47 correlation. So we want to figure out how many pounds that 0.94 standard deviations above the weight is. So now step 3 is going to be to take that, I'm going to call this z of y. So we're going to take that, 0.94, and multiply it by 1 single standard deviation. So if somebody was 1 standard deviation above the average on weight, they'd be 30 pounds over. This person's only 0.94 standard deviation, so they're going to be a little bit less than that. 0.94 times 30 is 28.2. So now we have somebody who is 76 inches tall, or 6 inches above their average height. The average height for men is 28.2 pounds above average weight for men. So the average weight for man, oh, I forgot to write this down. This was z of y times the standard deviation of y, or r times z of x times standard deviation of y. So now we're going to take that previous answer, zy times sdy, and add it to the average weight. So we get 28.2 pounds plus our average weight of 162 pounds gives us 190. That U was not a U, that was a, ooh, that's a nice one. 190.2 pounds. Nice one to add. Okay, we'll do the same thing for 64 inches and 69 inches. I'm just going to do 64. There's no reason to do C and B. I'm not going to do both of those. That's just a waste of time. If you're confused, you can rewatch this problem. I'm going to do the second one so you can see a second example of this. We're going to do the same thing. I want to know how much I would expect somebody to weigh if they're 64 inches tall. So note that that is underneath the average height, so we're going to be underneath the average weight. We just need to figure out how much under. So our average height is 70. So step 1, the z of x is 64 minus 70 over standard deviation of 6 is negative 6 over 6, negative 1. So somebody who is 64 inches tall is exactly 1 standard deviation below the weight. Step 2 is going to be to multiply that by the correlation coefficient. So somebody who is 1 standard deviation below the height is going to be 0.47. Sorry, I've been talking all day. 0.47 standard deviations below the weight. So let's figure out how many pounds that would be if they're almost half a standard deviation below the weight. What's the standard deviation for weight? 30. 0.47 times 30 looks like 14.1 pounds below the average. It is below, so I need a negative on that. So then we take that And our average weight is 162. If I do 162 minus 14.1 pounds, we get an average weight of, I don't know, I'm not going to do that one in my head. 162 minus 14.1, 147.9 pounds. Notice I did put units on it, because we have the units, we want to use the units. Okay, one more example of this. I want to estimate the final exam score, so I know the final is Y, given an 87 on the midterm, so the X is midterm. Average X, SDX, average Y, SDY. Step 1, figure out how many z-scores an 87 is above, or standard deviations above the average it is. So z for the X, or for the midterm, 87 minus 75 over 10, 12 over 10, or 1.2. So if somebody's 1.2 standard deviations above the average for the midterm, we can predict how many standard deviations they'll be above the average for the final by doing our correlation coefficient times that 1.2. So we get 0.84. So that tells us somebody who scored 1.2 standard deviations above the average on the midterm is probably going to score around 0.84 standard deviations above the average. Well, let's figure out how many points that is. So one standard deviation above the average is 12. Well, we're not scoring one standard deviation above the average. We're scoring 0.84 standard deviations above the average. So we'll multiply those two numbers together. I missed the 8. 0.84 times 12 is 10.08 points above the average, and the average on the final was 70. So they're going to score 80. We add these points. I would round that to just straight 80 points. I would not write 80.08 points or 80.1 points. Okay, this is that same exact thing. You're welcome to try it on your own and see if you get down to the same answer. Quick comments, 6 feet is 72 inches tall. So go ahead and pause this, go through those 4 steps, and then when you get done, come back and check to see if you have all the same work as what I got. Okay. You should have gotten 122.12. This is talking blood pressure versus height, right? Yeah. So, MM, I don't know what MM stands for in this case. A couple things to notice. This score, 72, was above average for the height, but then this 122 is below average for the blood pressure. And that's because it's a negative correlation. So as one goes up, the other does go down. The other thing to notice is this is a negative 0.2. That is a very weak correlation. And what that means is you can't take this prediction to be as very accurate. There's a lot of wiggle room there when you have a correlation that small. So it's very, very, very likely you will not see a correlation close to that. So, in regression, how do we decide which variable is x and which is y? And go ahead and choose which answer you think it is. Pause if you need to so I don't give you the answer away. Give the answer away to you. Okay, the correct answer is C. We know the x variable, we're trying to predict the y variable. That's always the case. We know x, we are predicting y. So we talked about in chapter, where are we at? Chapter 9, we talked about how you can't use R if the scatter plot is not a line, if it's got outliers, or if it's a curve. Same thing for regression. If you see a curve, avoid using regression, which you're not going to see because this is just an intro to stats class. But in the future, as you're taking other stats classes, if you see that, know that you'll be doing different regression. There's linear regression and then there's other regression, and you would be using, I don't know what it's called for a parabola, but you'd be using a different regression. Okay, I am not going to take the time to do this in this video. I am going to give you the answers so you can check if you want to, or so you can do them on your own if you want to, and then check to see if you did it right. But I think we've done enough of these. This one is 67. Notice you're predicting x from, or sorry, you're predicting the final from given the midterm. This one's backwards. You're predicting the midterm given, predicting the midterm given the final. You switch the x and y on that one. So A is 67. B is 72.84. So when you switch the two variables, this point, or this was a 81 on midterm, 67 on final. You can't go backwards and say if you got a 67 on the final, you're going to get an 81 on the midterm. We would have to start over because the variables switch. If somebody got a 67 on the final, they actually would have, or we would predict that they got a 72 on the midterm. Actually, 73 is what that would round to. So just keep in mind that if you switch the variables, that regression line does flip, and that's what we see on the next two slides here. This regression line changes based on if we're predicting for the final or for the midterm, and it flips. It's a vertical flip. It flips vertically over the SD line. Okay, so that's what that slide says as well. So if you're going to change the variables around, it doesn't change correlation, but it does change the regression line. So switching x and y does not change correlation. It does change regression. Okay, we're going to skip this pop quiz, and let me just summarize what happens in it. It doesn't really work to do this pop quiz because I don't have all of you guys in the classroom together, so I can't collect the data. So, with this pop quiz, I would ask you 3 questions. There are these 3 questions you would guess because you probably don't know the answer to them. And then I'd have you retake, so you write down how many you got right. So let's say I got 1 out of the 3 right. Then we'd retake the quiz. This time it's actually, we'd score what you got on it. So let me just show you. I'm going to pull up some numbers from a past class. We've at least got something in here. So the number of 2's was 42, and the number of 3's was 9. So that's how many people scored 2 of the 3 questions right, how many people scored all 3 of the 3 questions. And then the number of people who scored 1 was 54. The number of people who scored 0 was 29. And I want the average of the group that scored 2's and 3's. We're going to call them the top group. So to get that average, we're going to do 42 times, they scored 2 points, so this is their average score, plus 9 people scored 3 points out of a total of 42 plus 9, so out of a total of 51, and that gives us an average of 2.18. Okay, so the average for our top group is 2.18. The average for the bottom group is going to be 54 times those people scored 1 point plus 29 people scored 0 points, divided by 54 plus 29 What is 54 plus 29? I don't know. Let me find the calculator. 83. Okay, that is 0.65. So what I want you guys to notice right now, the top group, their average is 2.18, the bottom group is 0.65. That's the important information here. Then, the same group retook the quiz, different questions, let's score how many people got how many points right. This time, the same people, 4 of them scored 0 points, 11 of them scored 1 point, 17, oh, I'm sorry, I need to read this. So if you scored 23, or a 2 or a 3, so that's for my top group people, so that's this 51 people. 4 of them scored 0, 1 of them scored 11, 17 of them scored 2, 3 of them scored 13. That's a little confusing to you, that's okay. The main thing here is what I'm looking at is my top group. On the previous group, the top group had an average of 2.18. The average for these go by add, all multiply by how many points they got, add it all up, divide by the 51 students. The average was 1.87 versus the previous one was 2.18. So their score went down. So my top group score went down. Now let's look at the bottom group. So the people who scored 0 or 1, bottom group people, this was the results for them. So this is how many people scored each of these different options. The average was 1.71 this time, whereas our previous average was 0.65. So it went up. Okay, what this is called the regression fallacy or regression effect. And what generally happens is our people who do well the first time around don't do as well the second time around. Their scores decrease, and that's what we saw here was a decrease in score on the second quiz. Our people who did not do as well the first time around, their scores increased the second time around. The way I think about it is if you're already at the top, it's really hard to get farther than the top, so of course you're going to go down some. If you're at the bottom, there's nowhere else to go but up. So that's just a quick way to remember what happens with that regression effect. And that's what this slide says. Okay, attributing the regression effect to something other than chance error is a regression fallacy. And we see examples of that where we attribute that effect of scores decreasing the second time around or increasing the second time around. It happens a ton. There's a couple examples here you can read through. The best example is the Sports Illustrated jinx. And what happened in it was if you appear on Sports Illustrated cover, it means you're a really good athlete. And what they found is athletes who appeared on the Sports Illustrated cover their next season didn't go as well as the previous season. And so they started calling it this jinx. And you can read about it in your slides. Actually, you probably can't because it's moved to be tiny. There's a link for it right here. Oh, but that link doesn't work either. There's a link in the PowerPoint. Yeah, the PowerPoint link would work for you. Where they called it a jinx. It was the Sports Illustrated jinx. Basically, just what happened was those who scored or did really well appeared on Sports Illustrated and they did not have as good of a season. So they said, well, you better not appear on Sports Illustrated because you're going to become a worse athlete because of that. So that's a fallacy there because it's actually the regression effect, where if you're at the top, you're probably going to decrease just a little bit. If you're at the bottom, you're probably going to increase just a little bit. And that is chapter 10. Whew, we made it. Okay, so looks like I have previous cuts from previous years or trimesters. We're going to add even more to it. So this homework is due on a Friday. It should be Friday the 27th. And that's when I want you to have, actually, you know what, that's like, this is due Monday, March 30th, and we were supposed to go back. I want you guys all to have your homework done before March 30th, because that's when I want to start focusing for the exam, if not before that time. Okay, what we need is the homework. So the homework is actually just going to be, let me just cross this off and rewrite up. It is chapter 10, so set A. Set B, we're going to just do numbers 1 through 3. And set C is just number 1. So it's a really long video for a really short homework assignment. You're welcome. Thank you for sticking with me if you watched this whole video. That was probably not the most enjoyable moment of your life.